Just to reiterate, we have f of t, here's the graph of f of t, and we're defining a of x to be the area under this under the graph of f of t, or between the graph of f of t and the t-axis, from 0 to x. So for example, we can see that the area from 0 to 1 is 1, right? It's a 1 by 1 block. A of x has to do with the fact that as we drag t, the area changes, okay? It's positive here, then it starts to decrease. This cancels out the green, continues to cancel it out, so somewhere around here it's going to become negative because of the net change, and then the area starts to increase again. That's a of x. So for our second part, we just addressed the relative minimums. We're going to ask what the relative maximums are. In this case, I'll use the color brown for relative max. What are the relative maximums of a of x on the interval 0 to 12? Well, similarly to relative minimums, the relative max is going to occur whenever the area goes from increasing to decreasing. So we know that is true for the graph of a function, and let's just say this is a of x. We want to figure out where the area under this curve of f of t goes from increasing to decreasing. Okay, this is pretty interesting because it's increasing from 0 to 3. From 3 to 4, what happens? It actually flatlines. Okay, so the area doesn't increase at all. If we were looking at that as a graph, okay, it would look something like this. Okay, and then what would happen at t equals 3 that the area would be constant for a little bit. Okay, the area would be, for example, if I look at this right here, this is actually going to be, the area is going to be 2.5, right? It's going to be 2 by 1 here and then half of a block here. So the area will remain 2.5 for a while, and then it'll start to go down. Okay, and it'll start to go down because the area below the t-axis starts to drop, and it becomes negative. So this almost occurs at t equals 3, but it doesn't because it flatlined. Okay? So the fact is, and I'm not going to read all of this, I'm just going to explain it on the graph. You can read it later if you want. But the graph never goes from above the t-axis to below the t-axis at a single point in time. Hence, there are no relative maximums. So if I go back and kind of look at this little graph I drew here, we have a plateau here. We don't have an actual relative maximum, okay? Nowhere in this entire graph at a single point does the area go from increasing to decreasing. Here it goes from increasing to constant to decreasing. And therefore there are no relative minimums. Okay? I will draw an example of what that would look like. And then, so basically, if the graph were to immediately start to go below and start to cancel itself, then we would have a relative maximum right there. But because it doesn't happen, it flatlines for a little bit and then goes down, this graph has no relative maximum. So we look at the rest of the graph, it does go from decreasing to increasing, therefore relative minimum at t equals 10, but there are no relative maximums. So a little tricky, but that is the thorough explanation of it. If you have any other questions about relative maximums of an area function, let me know.